Assalamu alaikum, good morning, hello and welcome everyone to today's webinar, SeIRAS Digital Twin and IR 4.0 in conjunction with Hari Profesion Teknikal Negara. I'm your host, Shahriar Arwani, alongside my colleague, Dr. Hafiza, and we are live from KICT IIUM. We are glad to have you all tuned in. Dr. Normazia is unable to join us due to unavoidable circumstances. May Allah subhanahu wa ta'ala ease her situation. Digital twin is a hot new emerging technology space, but I promise you, this is a real thing and modeling is at the heart of it. It kind of seems complex, but that's why we are here today. We have in our midst three experts who are going to help the country steer through the new industrial revolution, IR 4.0. Let me quickly introduce our panelists. Prof. Muhammad Riza Wahiddin, Vice Chancellor of University Science Islam Malaysia, Dr. Mazlan, CEO of Favor IoT, and our very own Dr. Rizal Muhammad Noor from KICT. A warm welcome to all three of you. Our panelists come from diverse backgrounds. Prof. Riza is a well-known figure in cybersecurity and quantum computing. Dr. Mazlan has been a strong proponent of industrial IoT in the country. And Dr. Rizal has been extensively focusing on cloud and IoT research. If your friends and family haven't joined in, now would be the time to send that WhatsApp. We are live on Facebook. If you have any questions for our panelists, please shoot it on Facebook and we will be glad to answer.
Terima kasih Dr. Syahriar untuk pengenalan tadi. Kami sekali lagi sangat mengalu-alukan kehadiran semua peserta dan panelis ke sesi webinar kita pada hari ini. Seperti yang dimaklumkan tadi, sesi webinar ini adalah bersempena dengan Hari Profesion Teknikal Negara 2020. Bertemakan masa depan adalah kita. Sambutan tahunan ini adalah anjuran bersama agensi-agensi di bawah KKR. Tujuan sambutan ini selain daripada mengiktiraf sumbangan profesion teknikal kepada pembangunan negara, ianya juga adalah untuk memberi pendedahan kepada masyarakat tentang bidang teknikal itu sendiri. Dengan itu, tanpa melengahkan masa, kita akan mulakan dengan soalan pertama ditujukan pada yang berbahagia Prof. Bolehkah Prof berkongsi sedikit latar belakang dan bagaimana minat Prof untuk menceburi dalam bidang sains dan teknologi ini?
Terima kasih Dr. Hafiza. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semua. Minat terhadap sains dan teknologi ini datang daripada awal lagi di bangku sekolah. Dan satu faktor saya rasa membantu saya mencebur diri dalam bidang ini ialah filem dan kartun-kartun science fiction. Ultraman, ya. Benda macam Star Trek. Jadi benda tu dia memberi saya gambaran bahawa orang sekarang kata thinking out of the box. Memang masa tu kalau tengok memang thinking out of the box, nak mencari idea-idea yang tak dapat pada masa itulah.
Bagaimana Prof boleh terlibat dengan quantum computing itu sendiri, Prof?
Sebenarnya bila habis masa dulu dipanggil SPM, sekarang dulu MCE, sekarang SPM. So ditawarkan untuk keluar negara. So diberikan pilihan, beberapa pilihan dalam bidang sains dan teknologi. Jadi saya memilih nuclear physics pada masa itu. Tapi macam mana pun dia tak ada nuclear physics yang ditawarkan di UK masa itu. Yang secara khusus bagi program lah, sarjana muda. Jadi saya ambil physics. Daripada physics tu saya mula berminat tentang perkara berkaitan quantum lah, quantum physics. So di situlah mulanya pencabahan idea-idea dan minat dengan quantum physics.
Okey, terima kasih Prof. Tak sangka ya daripada cerita-cerita yang macam animasi macam Ultraman tu semua boleh mendorong ke arah bidang sains dan teknologi.
Ya.
Okey, menarik sekali. Soalan seterusnya, soalan yang sama juga kepada Dr. Mazlan. Seperti yang kita semua sedia maklum, Dr. Mazlan ni adalah antara pemain industri yang tersohor di Malaysia. Bolehkah Dr. Mazlan berkongsi bagaimana latar belakang Dr. Mazlan dalam menceburi bidang sains dan teknologi?
Okay. Pertama kali saya mengucapkan terima kasih kepada IUM kerana menjemput saya. Macam mana Prof. Rizal kata pun dia ada punya background tu melihat kartun kan. Saya ada cerita lain jugalah. Okay. Bidang karier saya memang dah selama ni dalam bidang elektrik dan telekomunikasi lah. Semenjak saya graduate daripada UTM tu, bila saya keluar, saya sebagai seorang akademik dan dalam bidang telekomunikasi itu sendiri. Sebab master saya adalah bidang telematics. Telematics dipanggil data communication. Itulah minat saya. Dan apabila saya keluar daripada akademik, masuk kepada industri pun dalam bidang telekomunikasi, minat saya masih lagi mendalam dalam R&D, meneruskan usaha-usaha R&D di sektor telekomunikasi itu sendirilah. Kemudian saya keluar masuk kepada MIMOS pun dalam wireless teknologi. Jadi benda tu tak pernah lari daripada bidang teknologi sebab minat saya memang amat mendalam dalam bidang teknologi itu sendiri. Sehinggalah masuk kepada Redtone, membuat satu bisnes dalam IoT itu sendiri sehingga umur saya agak lewat sikit lah untuk menceburkan diri dalam usahawan. Memang dalam cita-cita kita tidak pernah fikir untuk menjadi seorang usahawan ataupun seorang CEO. Saya punya resume dahulu pun setakat nak menjadi seorang CTO, Chief Technology Officer. Tapi kalau nak katakan minat tu datang daripada mana ialah saya masih ingat lagi ketika saya masih kecil, saya pun agak heran juga bagaimana bapa saya, seorang yang kerjanya sebagai seorang kerani, just normal clerk di sebuah kerajaan, tapi tidak ada secara formal mendapat kursus untuk membaiki televisyen ataupun barang elektronik. Tapi saya lihat di belakang rumah saya tu, dia setiap kali ada waktu terluang, dia akan pergi membetulkan televisyen daripada jiran-jiran dan kawan-kawan yang menghantarnya lah. Televisyen ke ataupun radio dan sebagainya. Apa yang saya ikut naik kereta, dia akan pergi ke kedai, dia akan dapatkan satu circuit diagram. Dan circuit diagram, saya tak tahu apa benda circuit diagram, masa kecil kan. Circuit diagram tu dia akan gunakan, dia boleh repair TV. Jadi saya tengok apakah rahsianya. Saya tengok ada satu buku, set buku mana radio elektronik. Masa kecil sebelum tu memang tak faham langsung lah. Jadi daripada situ pun saya mendapat minat bagaimana minat dalam bidang digital ini ataupun elektronik ini tu sendirilah. Dan kalau nak katakan kartun tu, kartun yang paling saya minat ialah Jackson. Jackson ni kalau kita kata tahun 60-an, IR 4.0 memang telah diperkenalkan dalam watak kartun tu sendiri. Kita tengok robot yang tak pernah kita reka bentuk, memang dah ada 60-an dah ada robot. Kalau kita tengok kereta terbang, memang tahun tu memang dah ada kereta terbang. Kita nak tengok video conferencing, kita nak tengok smart wearable, dalam kartun tu lah yang akan menunjukkan teknologi-teknologi terkini, padahal ketika itu teknologi itu belum lagi pakai lagi ataupun belum diwujudkan. Internet pun masa tu pun tak ada lagi. Dan tapi waktu itu mereka telah dapat memikirkan sesuatu yang visi yang agak jauh masa ke depan. Jadi itu yang minat saya datang. Jadi alhamdulillah saya masih lagi berkecimpung dalam bidang ini walaupun tidak dapat mereka bentuk robot, tapi bolehlah membantu serba sedikit dalam IoT itu sendirilah. Itulah minat saya.
Terima kasih, Dr. Mazlan.
Thank you, Dr. Mazlan. Favorite provides services such as Favorite Platform. It's a development platform for IoT developers. If you're interested, please contact Dr. Mazlan. They have FavorSense, which is a crowd sensing platform, Rakib, Discover, among others. I think Dr. Mazlan in the discussion will highlight a bit about all of these. On that note, let us move on to Dr. Rizal and ask about his background and his current ventures. Dr. Rizal.
Audio.
Mute. Dr. Rizal, you're on mute.
Okay, sorry. Just occurred to me that the two giants, Prof. Reza and Dr. Mazlan, are also ex-MIMOS. And I was also with MIMOS once upon a time. And similarly, you know, television show is what drive me to technology, just like Prof. Reza. Of course, my TV series is a little bit more modern. So my interest was then, I don't know MacGyver, but I'm sure a lot of people today wouldn't even know what MacGyver is. So it starts from there. And then I continued school, particularly in electrical engineering in Johns Hopkins. But I always like to tinker stuff. So you know, I always get scolded for dismantling things, never creating things, but dismantling. So dismantling the TV, dismantling the radio. But the interest is there. And until today, fortunately, I'm in a research institution where they let me dismantle things and explore, right? So so IoT is a big part of it. So we've played around with many IoT tools, partly also using Dr. Mazlan platform to handle the IoT devices. Right? So that's a little bit about me.
Dr. Rizal, on that dismantling note, how do you think that it has played an important role in where you are? Because a lot of researchers will have the same mindset.
Yeah, so I would say, you know, from it starts from 6 years old, as far as I remember, I start dismantling a lot of things, and from there on, we discovered the motor in a, you know, your radio control car, and how the motor moves, and you know, you start to be creative, trying to make your own radio control cars. Of course, we didn't have the theory. I didn't have the theory enough. So you know, there's no circuits and everything. But I think it's important for anybody to just let your kids dismantle stuff. I think it's the first form of learning.
Right. Just one more question before we proceed to Dr. Rizal. As you said, all three of you are from MIMOS. So how has MIMOS played into this journey of where you all stand? Perhaps Dr. Rizal, a little bit about yourself on that.
Sorry, me?
Yes. How has MIMOS shaped your journey?
Okay, so in MIMOS, we, you know, there's a lot of research culture where they started off there. Again, we are encouraged to explore. So my work there was mostly on software and open source systems. So I did have fun exploring on that side of technology. I would say there's some parts of freedom that you get in being a researcher there.
Thank you very much, Dr. Rizal. Digital twin is basically reinventing the industrial landscape with increased efficiency and least downstream defects. Let's watch a quick video before we dive into the discussion with our panelists.
The next big thing in industrial services, digital twins are being used to optimize the manufacturing processes. Digital twins simply means creating a virtual replica of the physical product. For example, a car, a bridge, aeroplanes, etc. Digital twins integrate artificial intelligence, machine learning, and software analytics with data to create living digital simulation models that update and change as their physical counterparts change. Digital twins are used to optimize machines with the maintenance of power generation equipment, such as power generation turbines, jet engines, and locomotives. Digital twins will increasingly be used in many areas such as building management, smart buildings, healthcare, oil and gas, smart cities, and far more. Engineers can get information of usage in the real world and can include the information they gather for further development. The digital twin gives easy access to advanced product asset maintenance and management due to its real-time nature. Decision-making is easier in highly complex cases. For example, digital twins helps in optimizing processes, reduce physical effort, and helps control all aspects virtually. With the help of this technology, consumer insights and behavior data gathered can help improve product development and innovation in a more data and customer-driven way. As David Surley suggests, over time, digital representations of virtually every aspect of our world will be connected dynamically with their real-world counterpart and with one another, and infused with AI-based capabilities to enable advanced simulation, operation, and analysis.
Wow, that's a lot of productivity, real-time sensing, analytics, and improvement. I'd like to ask Prof. Riza. Prof. Riza, welcome again, and my pleasure to ask you, what is your opinion about digital twins?
Okay, thank you, Dr. Sharia. We start off by comparing biological twins. So to make it easier to understand, biological twins, if we have, let's say, 2 of these or 3 triplets and so on, but of course in our case it will be twins, you must have, in this case, a real physical object and its equivalent digital, mirror. So that's why we call it digital twins. So if you don't have a physical object to relate it to its corresponding digital twin, then we have the difficulty of trying to understand why is it called the digital twin. So as we've seen in the video, there are a lot of things that we can do with digital twins, but then of course also apart from opportunities, we do have challenges.
Prof, can you highlight on that challenges part so that we can look into the difficult side first?
Oh, you want to study on a negative note. All right. All right. So you need some form of knowledge. You need some form of experience. And if we look briefly into the video just now, many of the things in order to realize digital twins are leveraging using mature technologies. So it's not surprising because if you're talking about modeling, simulation, augmented reality, all these things are there. Of course, they will be improved over time. But then again, we are taking bits and pieces of these different knowledge, know-how, technologies, put it into a package, and we are calling it digital twins. So the challenge then is you need the person to have the know-how. So if we are talking about modeling, you need somebody who knows what are the components of the object that you want to model and how close is the model to the real physical object. So I'll stop there for the moment.
I think so. So I think if I get it correctly, you're talking about domain knowledge expertise will be very, very important in this case.
Precisely.
Exactly. So I think we will come back to that point later on in the panel discussion, where we'll be talking about how far is Malaysia in terms of achieving this digital twin. Thank you, Prof, for your explanation.
Welcome.
Kita nak tujukan soalan yang sama lah kepada Dr. Mazlan. Apakah pandangan Dr. Mazlan tentang digital twin?
Okay, thank you very much. There are terms which sometimes we only realize today, like digital twin, quite recently. But in fact, just like IoT, digital twin is also focused some time ago, many years. I think like IoT itself, I tell you that IoT is not something that we have coined up the term the last 5 years. It's since 1999 by Kevin Ashton. And the same goes with digital twin itself. It's actually since 2002 by Michael Graves. But why at that time we are not very familiar with that technology, like what Prof. Reza had mentioned, is because there are certain new technologies that come in place which make this possible. Unlike initially when, like computing power, in terms of internet connectivity, in terms of sensor technologies, miniaturization of electronics and all that, it was not possible at that time. So only now that we are now seeing this going to be materialized. So when I look at the video just now, it's all about data, right? We have seen a lot of data that goes in and out. And I remember the days of how we do research. In fact, when we do research, there are actually, you're doing R&D, there are three methods normally that people will use and validate their research. One is through analytical, which is mathematical model. People like Professor was very familiar with mathematics. He must love mathematical modeling. People like me, I don't like mathematics, so I might use a different approach. So the second approach of doing R&D and validating your result is through simulation. You're going to model in computer systems with your basic assumptions, how the traffic going to be like, how the certain parameters input that you're going to assume how it's going to behave in a digital world. So based on simulation. And the third one is using experimental, which is very expensive way of doing things, right? So normally you need to set up a real infrastructure. You need to purchase a lot of hardware, sometimes software, just to make a setup, a small scale setup. But it's very difficult for you to scale up when using experimental work. Simulation you can do, but once it goes into very detailed simulation, it's also very difficult for you to simulate things. So what happened now is that digital twin actually combine the world of this physical, doing experimental work, and simulation together. That's why you have that both the physical part, the real, and the simulation, which is on the digital world. They are digital twin. So what you need is the most important part when you look at the video is the need to able to capture the real world situation, and you need to simulate this model, and of course you can able to predict the future. That's what digital twin is all about, because with that you can do a lot of wonders, right? Instead of instead of building the whole infrastructure from day one until the end, and then you found out the result is not good, you might as well able to simulate it. But having a real data input is much better. So that's why it tries to capture using sensor data. So IoT and all that, we'll explain later how you want to capture that. And based on that real data, you can turn into digital and having that twin part, like Professor mentioned, either a digital twin or triplet or whatever, you can have that if you want to. All right. Okay.
I think it's best of both the worlds. You have the experimental side and the simulative side, and on top of that, there is prediction. And a lot of technologies, as Dr. Mazlan said, are readily available, which would not have been, let's say, a decade ago. So the landscape is changing very fast, right? On that note, let us ask Dr. Rizal, in context of what Prof. Riza and Dr. Mazlan has discussed, where does Dr. Rizal see the research and development, or the digital twins research and development?
Okay, thank you, Dr. Sharwani. Right. So, like they said, a decade ago, these technologies was not there. We had internet, but it wasn't as good as today. Today we have 5G, and this is an important part of having IR 4.0 and even digital twin. We have embedded devices that are low power, much smaller today. We have AI platforms that are being developed by popular companies like Google, Amazon, IBM. We have cloud infrastructure. We have security in the cloud infrastructure. We have blockchain that is coming and maturing, right? So all of this actually introduce and makes it possible for digital twin, right? Now, having all of this, it's interesting because before, all of this was just a idea, right? And we don't really know how we want to apply it. And having all these technologies available to us allows us to create new solutions, right? So I'm looking into a research area where where we can apply digital twin that can extend the human capabilities, right? So, so that a human being can have foresight, such that, in situations where we can predict when is a flood going to happen, or for example, what's going to be the crop yield in this month, right? All with digital twin technology, right? Having foresight like this makes us becomes shamans, bomo, right? Capable of making predictions before it happens. Right? Also, we are looking into, augmenting our visual side, right? Capable of becoming Superman. We can see the insights of a person by having a person digital twin, an engine, right? So all of this actually, the whole idea is making us superhuman, right? Superheroes, because the digital twin has, will extend our ability to view things, and these are all sound science fiction, but it is a fun area to do research, and it's a fun area to figure out whether we can shape, whether we can make science fiction into a reality.
Okay, terima kasih Dr. Riza. Nampaknya kesediaan teknologi itu sendiri memainkan peranan untuk nak tengok kita dah bersedia ke belum untuk dive into digital twin ni. Untuk meneruskan sesi kita, mari kita tonton satu lagi video berkaitan dengan digital twin sebelum kita meneruskan dengan perbincangan yang seterusnya.
Innovation is a journey without an end, work that's never done. We're constantly pushing the possibilities of our physical and digital worlds that are increasingly converging. Driven forward by technology, from cloud to the edge, AI, and IoT. Now allowing us to create digital models of our physical spaces, called digital twins, creating the stories, touchpoints, and solutions by realizing the relationships and interactions between people, places, and devices. And with the promise of AI, we can uncover insights that see problems before we experience them. We can better understand needs and improve experiences. We can see, learn, and even predict how people move through and interact with the spaces around them. Connecting these stories and data to power modern business, building new possibilities in real time. Made possible by our partners and an end-to-end 3-cloud capability, Azure, Office, Dynamics. Help bring to life smarter spaces that connect to a digital world and turn new possibilities into new realities.
Okay, berdasarkan video yang kita tonton tadi, kita dapat lihat beberapa komponen penting dalam digital twin. Antaranya artificial intelligence, AI, Internet of Things, IoT, dan juga ada keselamatan cyber itu. Mungkin Dr. Mazlan boleh berkongsi dengan kami bagaimana peranan IoT dalam digital twin.
Okay, terima kasih. Kalau kita lihat secara asasnya, IoT itu sendiri mempunyai 4 komponen yang penting untuk kita melaksanakan sesuatu IoT punya implementation. Kalau kita tengok yang pertama itu adalah sensors itu sendiri. Jadi kalau kita lihat sensors ni, manusia mempunyai 5 deria, 5 sensors, tapi dalam bentuk digital. Sebenarnya kita boleh tukarkan dalam bentuk yang lebih banyak daripada 5. Temperature, humidity, local accelerator, proximity, ambient temperature, gas sensor. Manusia pun tak boleh even detect apakah gas yang ada dalam bilik kita. Yang kita tahu hanya oksigen saja. Tapi mungkin oksigen, berapa peratus oksigen pun kita tidak tahu. Tapi dalam bentuk digital, kita boleh dapat lebih accurate lagi dalam untuk measurement. So sensor adalah komponen yang pertama. Itu adalah amat penting. Yang kedua adalah bagaimana kita hendak menghantarkan maklumat tu, data daripada sensor ke tempat lain. Jadi kita memerlukan connectivity. Dalam keadaan tertentu, connectivity ni tidak akan sama. Kalau kita berada di luar bandar, dalam rumah, dalam bangunan, bawah bangunan dan sebagainya, connectivity-nya akan bergantung kepada keupayaan dan suasana tersebut. Mungkin kita boleh gunakan seperti Bluetooth, Zigbee, RFID, kita boleh gunakan Wi-Fi, kita boleh gunakan teknologi seperti 3G, 4G dan sekarang 5G. Even now kita ada teknologi macam Narrowband IoT, Sigfox, LoRa, itu teknologi-teknologi IoT yang baru. Disebabkan kita memerlukan device kita adalah low power, jadi kita kena hantar lebih jauh, dan teknologi macam NB-IoT, LoRa dan sebagainya, dia lebih mampu untuk guna pakai ketika itu. Jadi bila kita dah menghantar data tu, kita ada kena satu tempat, ada satu platform untuk menggabungkan semua data, integration. So kita ada middleware, IoT platform. Sebagaimana Fabric yang bangunkan, kita ada platform ini untuk memudahkan data-data itu untuk di-aggregatekan. We-aggregate into one source, one platform. Jadi bila data tu dah sampai di situ, apa kita guna untuk data tu? Jadi komponen yang keempat ialah aplikasi itu sendiri ataupun analytics. Kemungkinan kita akan menggunakan machine learning ke artificial intelligence, analytics engine untuk menganalisakan data, derivekan data tu inside. Jadi kalau 4 komponen ni, kalau kita sambungkan kepada sesuatu aset, sesuatu produk. Kalau kita lihat tadi dalam bentuk video tadi yang kita tengok video tu, kalau kita ada satu produk atau aset yang kita nak monitor, aset tu dibangunkan oleh sebuah syarikat, katakan kita satu syarikat dia bangun satu aset, dia monitor aset ni, dia boleh tahu siapa yang memakainya. Jadi sensor apa yang kita letak, mungkin kita letak macam RFID-nya sensor kan, ataupun apa dia guna, who, kemudian kita nak tanya what features yang dia pakai, di mana yang dia selalu pegang, di mana yang dia guna pakai. Dan kita nak tahu juga kedudukan aset tu, where exactly the asset is going to be. Dia akan diguna pakai di mana. Yang keempat, mungkin kita nak tahu when, bila dia pakai. Adakah waktu siang, waktu malam dan waktu sekian-sekian. Kita nak tahu juga. Dan kita nak tahu how, macam mana aset ni, kata orang tu, how dia being used in the normal environment. Jadi dalam penggunaan aset ni, kita akan tahu aset ni digunakan untuk apa? Untuk mengoptimalkan proses dia ke, untuk mengurangkan tenaga manusia untuk digunakannya. Jadi kalau kita sambungkan data-data ni, sensor ke bentuk ke aset ini, produk ini, dan kita akan translate dia ke dalam bentuk digital, dan kita akan lihat dalam bentuk digital tu kita dapat data, kita akan lihat secara real time data itu digunakan di mana. Sebagai contoh, kalau aset tu kenderaan, kita tahu kenderaan tu pergerakannya di mana, kelajuannya di mana, dan dia waktu bila yang dia dipakai yang paling peak hours dan sebagainya. Jadi kita tahu tentang penggunaan aset tu. Rather dan kita duduk dan lihat aset tu dengan mata kasar kita sendiri, kita hanya menarik data tu ke satu tempat dan kita boleh guna pakai data tu untuk derive the insights of the information. Jadi dengan 4 komponen ini, itu yang menyebabkan IoT dalam Digital Twin itu begitu, kata orang tu, pentinglah komponennya. Sebab tanpa IoT ni, data tidak akan dapat di-aggregatekan dan dianalisakan. Itulah yang dikatakan kegunaan IoT dalam Digital Twin itu sendirilah.
Thank you, Dr. You have a question, Dr. Rizal. Please go ahead.
No, it's all right.
Okay, thank you, Dr. Mazlan, for that insightful explanation on DT, IoT, AI. We'll come back to you. In terms of Dr. Mazlan, who has been a proponent of industrial IoT, IIoT, any business that deals with the production or transportation of physical goods, this IIoT can be really game-changing in terms of operational efficiencies. And you can actually revamp your business models completely. And you'll be surprised to know that the applications are diverse. They range all the way from production to supply chain, building management, even healthcare, to retail, among others. Dr. Rizal, we'll head to you. Could you tell us about the expanding domain of artificial intelligence and cloud computing in view of the digital twins specifically and generally in view of the current industrial revolution.
All right. So we're talking about two areas here that has been significantly matured the last couple of years. So if we're looking into the cloud architecture or the cloud services, it has been around. We have a model to provide pool of services, in the forms of network, server, storage, applications, the services that are available, right? But today things are getting cheaper, right? In the beginning we have on premises, those things are expensive. So if you were to try to build anything, would cost you a lot of money. And then we had virtualization, where we have infrastructure as a service. And then today we have something even better. We call it container as a service, right? And then we're moving further into things like what we call platform as a service, right? So now Amazon, for example, have taken a step further where we have function as a service, right? So this is a bit more complex than just, we call it a serverless architecture, where, if you want some application to run or to provide some kind of function, you no longer require a server, right? You don't need any infrastructure in that sense, right? Or so all you need to know is some programming language and deploy it on a serverless architecture, right? Now, those new things basically allows people to implement something really cheap, right? So you don't need anything significant spending. So you just use pay as what you use, right? Now, in the AI area, AI platforms, today we have a lot of things going on. Particularly the algorithms have improved by far. So we are able to do a lot of machine learning computation that works very efficient, right? Now they have pushed this into providing APIs. So people like IBM Watson, Google Node provide analytics and provides AI platforms that you can pay as a service, and you can make your application become intelligent, right? So previously when we think about building these kind of things, it sounds almost daunting, very difficult, right? But today, if you want to implement a facial recognition IoT device to open a door, right? This simply can be done by just for free, but right, using your free account on Google Node, right? And you can test your prototype on a serverless architecture, and and then you have a IoT device with facial recognition, right? Smart enough to recognize who's coming in and to open the door, right? So all of this readiness in the industry, right? With the cloud computing, with the AI architecture platforms that they provide, brings down the barrier of entry. Whether we're talking about research, or we're talking about application development, or we're talking about coming up with product in that ecosystem. So we have switches that are smart today, right? That works in the IoT environment, that can study the network environment by just using the AI platforms provided by AI providers.
You make it sound very easy, Dr. Rizal. So I would like to ask you, when you say you use the words as a service, platform as a service, or serverless architecture, or the services that are now online from different corporates like Microsoft and so on, would you expound like one or two more examples of how things have become easy, which would have been difficult in the past?
Yeah. So for example, right, when we talk about AI as a platform on the cloud, right, in order to do computation, you require a computer that has a very high-end processing power with several GPU cards, right, to do fast computation, right. This machine usually costs a few thousand, right, and the barrier for entry, if you're just a someone who likes to tinker, or if you're a developer, this would be out of your scope, right, as for financial wise, right. But today, these services are available for you to play around with, that hardly cost you anything, so you can start developing your smart solutions, right.
And we will continue our discussion with our next panelist, Prof. Riza. Dr. Hafiza has a question to ask.
Terima kasih Dr. Syahriar. Saya ingin bertanyakan dalam konteks yang samalah kepada Prof. Tadi kita nampak ada komponen artificial intelligence, cloud, IoT. Bagaimana pula peranan keselamatan cyber dalam digital twin?
Okey. Kalau kita lihat seperti Dr. Mazlan sebut tadi, yang menjadi dia punya core di sini iaitu trust kepada kejayaan digital twin ni, itu adalah data dia. Data. So kalau kita lihat data tu, pertamanya seperti awal tadi saya sebutkan, kita perlu adakan satu model untuk menjadi digital twin kepada objek yang kita cuba jadikan sebagai SeIRAS itu. Kemudian bila kita dah adakan this digital twin ataupun model, perlu adakan data yang boleh dihantar daripada objek fizikal tu kepada model yang kita bina. So data ni bila dia datang, dia hendaklah sesuatu yang berterusan. Tidaklah semestinya setiap saat, tapi dia kena berterusan supaya kita boleh masuk ke dalam model itu dan update. Itu komponen ketiganya, updating. Model kita itu statik, dia tak boleh menjadi sesuatu. So kita kena ambil data yang dimasukkan kepada model itu, dan kemudian model itu akan bertindak balas supaya dia akan dapat seolah-olah memberitahu kita objek fizikal itu akan bertukar seperti yang sedemikian mengikut masa yang kita sedang perhatikan. Jadi saya nak bagi penekanan di sini bahawa lazimnya digital twin ni digunakan untuk dipanggil high value ataupun high end application, dan juga untuk safety critical application. Maksudnya kalau kita ambil autonomous vehicle, kereta yang tanpa pemandu. Autonomous vehicle ni kalau kita bayangkan, kalau kita duduk dalam taksi yang autonomous vehicle ni berjalan, dan kita sangat percaya kepada kenderaan ini. So data yang kita suapkan ataupun has been fed into the model ensure the autonomous vehicle itu sebenarnya is the real object physical, sedangkan sistem yang memberi tahu atau berkomunikasi dengan dashboard dalam autonomous vehicle tu ialah digital twin dia. So data sedang berinteraksi dengan apa yang berlaku di sekitaran kenderaan dan apakah kenderaan itu nak lakukan. Kalau data itu dimanipulasi oleh seorang hacker, sudah tentu dia akan membahayakan mereka yang duduk dalam kereta itulah. So ini satu benda yang saya rasa mudah nak diberitahu bahawa the data must be trusted, the model must be trusted, as well as updating of the model must be trusted. So kalau kita tak ada perkataan trust tu, which is the core of information security ataupun cyber security, then digital twin is not really helpful. So sebenarnya cyber security is very much at the heart of digital twin. Kita tak ada mengambil kira keselamatan maklumat dalam digital twin ni ke perkataan yang kita sebut tadi trust tu tak dapat diwujudkan, dan dalam aplikasi-aplikasi yang sangat penting seperti autonomous vehicle tadi itu, dia boleh membahayakan dan beragut nyawa.
Okay, terima kasih Prof. Jadi security requirement, kita balik pada security requirement saya, kita perlu ada confidentiality, integrity, dan paling penting sekali availability of the data lah kan Prof.
Betul, betul.
Okay.
So
yeah.
it looks like cybersecurity is the bloodline, from the heart of digital twin. Prof, it is not possible to implement such an architecture unless you can promise the security of the entire architecture. Prof, from experience?
Yes, it's true indeed that, as I said, the digital twin is most useful, especially in high-end or high-value applications, as well as safety-critical applications. And in these circumstances, we cannot afford to compromise the cybersecurity of the applications, and hence we have to put all our efforts to ensure the, as Dr. Fiza mentioned just now, data in use, data at rest, data, in motion. Yeah. So which means we need to look into the confidentiality, integrity, availability of data.
Okay, Prof, now that we have discussed the technical background, what DT is, and the other aspects, I think a challenging question, especially in terms of the pandemic that we are facing, and the IR 4.0 was also in motion in the country. So what do you think? What are your thoughts about the technical career pattern in the era of current industrial revolution, given that we are still trying to survive the pandemic?
Yeah, I was recently looking into job street, not because I want to look for a new job, but I'm trying to help my daughter to find a job. And when I type in, for example, physics, immediately things coming out from the search, data scientists, data analysts, the trend now, what is trending is people are talking about somebody who can, crunch the data, make sense of the data. So it's a matter of time when Malaysia will be looking towards the next phase, which is data, data twin, kind of experts. So these are the things that we have to look into right in the near future. So if we are looking into COVID-19 issues, one of the things that digital twin may be useful is to look into how this virus is able to evolve and mutate, and then we may have a model to to follow through. What are the things that are giving it the food, for example, the environment that is very conducive for this virus to spread, and in the end we'll be able also to complement that new knowledge with vaccines, new knowledge on how to handle this kind of pandemic.
So on that note, when you mentioned about the job street and being a vice chancellor at a university, considering the students and your daughter in particular, a lot of people are jumping into the area of big data analytics. There's a lot of jobs coming in. Do you think that we need to jump in at such a pace? Because eventually the market is going to get saturated, right? And then the job market is again, people are going to struggle again. So what are your advices on that end?
My advice to all of us, including my daughter, of course, is to be multidisciplined. That means you don't need to be, focusing on just one specialization and ignoring others. So a simple definition of creativity is to make the connection between two things that may have not been connected before. So from history, we've seen quite clearly scholars, whether they are Muslims or non-Muslims, they have been very much multidisciplined. So, if you have some exposure to social sciences, and you also have some exposure to the STEM or SNT, science and technology background, nowadays I think some of you adik-adik di luar di sana mungkin Google umpamanya citizen science. Citizen science adalah satu bidang. It is a discipline where you do not need to be an expert in science, but you are sharing your expertise and your know-how with others from various disciplines to promote SNT.
I will ask one more question before we head out, asking Dr. Mazlan. Prof. Riza, being a multidisciplinary yourself in an age which was, I would say, comparatively more difficult than we have a lot of ease today. In your own time, how did you manage to, bring together all those disciplines and try to carve a niche for yourself?
Yeah, thank you for that very important question. I started off by referring to science fiction, movies, dramas. You carry on with this kind of hobby. You'll be able to, complement whatever you get from reading books and also interacting with different people. So from there, you'll be able to find out what are the things that are, the pain points in society today, and what are the solutions to alleviate these pain points. So on one hand, we started off just now with an overview of about digital twin at 30,000 feet. But on the other hand, we need to bring that 30,000 feet down to around 3 feet nearer to the ground. So that is where it means most to, people are asking to be able to withdraw their money from EPF, KWSP. These are real issues. And we are here to solve problems, not to just give ideas and no follow-ups.
Terima kasih, Prof. Pandangan yang menarik sekali. Imajinasi tu penting, Prof.
Yes.
Imajinasi kita relatekan dengan real world problem lah kan?
Correct.
Terima kasih, Prof. Okey, Dr. Mazlan sebagai pemain dalam industri lah, mungkin doktor boleh terangkan sedikit bagaimana corak kerjaya teknikal dalam era IR 4.0 ni.
Okey. Agak kompleks. Dia lebih kurang macam inilah. Apa yang kita lihat, kita kena menyediakan tenaga kerja kita dengan skill-skill yang berbeza, bergantung kepada industri atau bidang mana yang mereka nak ceburi. Sebab sekarang ni pun kita tengok the technology have been converged, the technology convergence. So it's no longer like you are specialized in one certain apa kata orang tu technology, but you want to neglect others. Even like myself, I've been working on various technologies, try to understand because this technology depend on each other. For a start, if we want to do in Malaysia, for example, in the new technologies, emergence of new technologies and the adoption of new technologies, there are few people, there are a lot of talents that we require to support to ensure that this technology or this new way of thinking going to be very successful in any countries, because there are 4 things that we need to do, and we need these 4 kind of people. One, we understand that if you launch something, we need to do some trial first, kan? Normally when we do trial, the trial needs to do because we need to understand the technology maturity. So understanding the technology maturity will enable you to see whether the technology is safe enough, matured enough to be deployed in the real commercial world. Secondly, when you want to do trial, you also want to understand the market adoption. Market adoption means that technologies like driverless car, driverless taxi. Who wants to take a taxi where there is no driver at all? Do you think women would take it? So we need to understand the market adoption, the user experience. Are you willing to take a flying taxi? So that's why you need this kind of trial to understand how the market will adopt. Thirdly, because the complexity of these new things, that we are disrupting a business. So we must find and think about the new business models. Are we going to charge the normal way of charging? Hey, you buy my system, that's it. I just tend to forget about that. Or you want to subscribe to my services. Or nowadays, they call it outcome-based business model. Meaning to say, if you reach to an outcome, you will pay for that service. If you don't meet the outcome, you don't pay for the service. I want to arrive in KL within 30 minutes. I will take the flying taxi because it guaranteed you within 30 minutes you will arrive there. Otherwise, you don't pay me that amount. Okay. And the fourth part is that you need to understand the policy and regulatory needs to be changed. So policy and regulatory plays a very big important role, because if you work in that area, if you are trying to start, if you control the policy and regulatory, it can stifle the innovation. But you also want to ensure that the citizens are safe in using the technology. The business are safe, the people are safe. But don't tighten in so much that you don't know whether you can deploy this and use the technology. For example, like Gojek, Gojek in Indonesia, people can go for ride hailing, right? Motorcycle ride sharing. Malaysia at one time, they go not being approved because they don't know. The regulatory cannot say that you can carry another passenger behind you. So it's regulatory have to change. So in a driverless car, do you think that driverless car that is a regulation stating that this car doesn't have any driver or no steering? The term of a car have a steering and four wheels, for example. So the new definition have to change. So what I'm saying is that the people, the new talents that we want, have to understand these four cases, four scenarios. If you want to work in the regulatory body, you also got to understand that this new talent that you want to, encourage innovation, but protect the citizens. And when you build your technology, you have to ensure that it's really mature technology and make it safe for people. If you are in the business part, you got to understand technology will not sell unless people are going to use it. So these are the new talents have to have that kind of thinking. All right. So other than that, that's for more the external part. The internal part is more about the change management, the way that people think about this digitalization. Is it going to change? How is it going to change? Are you going to face a new generation, which, older generation, which is not adapt to new technology against the Gen X and the Gen Y and the Gen Z is very tech savvy? You want to see that the processes that you have been used before, maybe one very long process with digital is going to be reduced. No more red tapes. You don't have power anymore for people who want to sign that your signatory. So you might lose some power. And then the culture may have changed. The culture of inside an organization, maybe it's flat structure because easier for you to communicate. You need to understand that you cannot no longer work in silos. You need to break down all the barriers. So you must have champion in certain projects. So, and of course, you need to build new talents. Technology comes and go, like cycle. Technology life cycle, they go at one time, it's very peak. After that, it goes down. A new technology comes in. So you need to quickly give the staff new knowledge for them to build quickly in order for them to adapt with this new technology. Otherwise, if 3 to 7 years, if the organization is not going to change, it's going to become obsolete. Your product is going to be obsolete. Your organization also cannot compete. So in this case, what we are saying is that the new talents of the IR 4.0 must be very agile also and understand the trends, what's coming. Because it's no longer like 100 years a technology come and go. No, it can be like 5 years, 10 years. The technology life cycle just exists today. So even the universities, they need to change again and again. By the time you refresh your content, new technology comes in and you have to introduce new technology. So you're trying to keep up with all this pace. All right. So we have to do that. So not only the technology is going to be fast changing, the way the process of approving, new contents inside the university also needs to change too. So to quickly change, to adapt to the industry needs. Okay.
Terima kasih Dr. Mazlan, menarik sekali. Walaupun kita dalam era IR 4.0 ni nampak macam semua dikontrol oleh sensors, nampak sangat automatik, tapi ada peranan insan tu di situ. Okay, jadi untuk teruskan, kita ada sediakan satu lagi klip video tentang Digital Twin. Jadi kita sama-sama tonton.
For example, the digital twin of an electric motor not only showcases form, but also analyzes functions, from the rotation of the shaft to thermal conductivity to data from sensors and beyond. What's more, the digital twin continuously evolves, thanks to the flow of data, user experience feedback, and new input, and it's greatly impacting development, production, and operation. In development, a product's behavior can be simulated and tested long before a physical prototype has been built. Siemens utilized the digital twin to develop a world record-setting electric aircraft motor that not only weighs 50 kilograms, but is also 5 times more powerful than comparable electric motors. But it doesn't stop there. Digital twins also unleash the power of 3D printing. In a recent Siemens study for gas mixing systems, insights from the simulation of form and flow behavior were combined with generative algorithms. The result? A truly unique channel shape and configuration, one significantly more efficient than anything previously designed. Even entire factories down to individual machines can be simulated and tested. For instance, robots. It's difficult for them to perform milling tasks because large forces in the manufacturing process lead to inaccurate movements. But with the digital twin, the forces that push the robot away from the milling path can be calculated and compensated in real time, keeping the robot in its path. When it comes to operations, digital twins can compare the sensor data of a real point in real time with the simulation of its point. The availability of the point parallel to operations can be reliably predicted, and sudden disruptions become a thing of the past. But this is just the beginning, and Siemens is already driving the future. Merging digital twins with artificial intelligence allows computers to independently design advanced products. Siemens is realizing this potential right now with Californian startup Hackrod, which aims to build customized sports cars. For development, production, and operation, the digital twin breaks with traditional paradigms and opens up extraordinary possibilities. That's why digital twins are the innovation backbone of the future.
Innovation backbone of the future. And I would like to take this opportunity to ask Dr. Mazlan about what he was discussing. I'm quite interested when he touched the subject of regulation and regulatory bodies. Dr. Mazlan, you've been in the industry for quite a long time. You have been a proponent of industrial IoT, and you actually have many ongoing projects under your belt. So you have hands-on field experience. So on that note, what do you think? How practical is digital twin for Malaysia? Do you see applications of DT here? A few questions actually. Are there any big players or emerging ones that we should be looking forward to?
Okay. In any new technologies, it has to go through certain phases of adoption. When we started off with IoT, it was not an easy journey for many organizations because one of the things is that people are not aware about IoT itself, for example. Just to be fair to say that, when exactly that you really Google the word IoT to really understand IoT. So when we look at Google Trend, there's a tool called Google Trend. You said Malaysia, you choose IoT. Malaysians start to Google IoT since 2014. Remember that? When the term IoT had been coined by Cabinet Action in 1999. was many years ago. So now you're talking about digital twins. I haven't got the time to Google it. So if you try Google Trends, digital twin in Malaysia, when do Malaysians start to Google digital twins? To be fair. So if it says that only last 2 years, so it's still a very new journey, even though it has been coined by Michael Graves in 2002, right? So it has to go through that process. One is the process of understanding it. One is the process of research and development. The moment it's stable enough, it goes to commercial. The moment it wants to go to commercial, it takes some time because we need to educate the industry, education of industry. So IoT have gone to that phase of educating the industry. So now it's the same phase with what we talk about AI, for example, blockchain, for example. They are now undergoing what we call education phase. So if digital twin is just only recently for 1 or 2 years back, so it's going to take a little bit more time for them to educate the industry. The industry is, there are two things. One is the technology providers, and the one is actually the one that consume. So the technology providers, people like us outside here, are so eager. They want to implement. But the question is, are you ready inside the organization? Are you ready to adopt and embrace digital twin? So you have a solution, but you need also the consumer the demand side to use it. So this is also the challenge. So you need to build that demand, make sure that they understand the real need for digital twin. So what we are seeing in Malaysia, a lot of organizations are still in the technology, the provider themselves, the one that supply. The demand side is still a bit of challenging. They need to understand the usefulness of digital twins. So we need, by hook or by crook, we still need to have, what do you call that? We need to educate the people out there. We have seen organizations, the one that, vendors who are very good in this digital twins is like the video that we have seen, Siemens, General Electric, Cisco, Dassault Systems, Microsoft, Oracle, PTC, ANSYS, IBM, Bosch. These are all the IR 4.0 organizations, right? So you know that. So because they are good in 3D printing, they are good in IoT, industrial IoT, they're good in digital transformation. So you have to go to that process first. But who are the ones that adopt it? Something which we need to ask for the next panel to answer, if they can answer this. Okay, I'll pass back to you, Doctor.
I think at this point of time, do you think that, so one thing you highlighted was education, and we're going to come back to that. The other thing I want to ask you is that, is affordability an issue of DT in Malaysia at the moment?
Yes, there are few factors which impact normally this kind of new adoption of this. One is the most difficult part is the mindset transformation. They need really to understand that this is really a need required, because if they don't transform, they might face issue of competitiveness. But in the case of digital twin, mainly this is meant for the SME or the people who produce things. They want to produce products which they can predict how the product's going to look like. So these are the users themselves, not using the traditional way of building it at 2 years, and then after that they just launch it, and then they have a problem, they come back to the lab and rebuild it. So it's going to take a longer time. That is the era of IR 3.0, 2.0 sort of thing. This is era IR 4.0. So they need to use the technology themselves. So I think that's how I think we are seeing the challenge that we are facing now.
Okay, one quick question before moving on. So in terms of education of the technology, do you think that universities, or in what capacities do education institutions play the role? Because this is where your next gen is going to come out from. What kind of role do universities play in this transformation?
I've been working very closely with them since 2014, and I've seen the changes in many universities. They have already embraced and refreshed the contents based on the needs of the industry. But of course, there are challenges. I mean, the universities need to validate this. But from us, we are seeing that sometimes the moment we make changes in the coursework, it takes them 1 year or 2 years to get it approved. So that process is something, it's a weakness that, a challenge that they need to face, because technology moves very fast. They cannot wait for 1 or 2 years down the road. But we are seeing the changes in the universities. And of course, they are the one that should supply the right talents.
Thank you, Dr. Mazlan. Thank you. Prof, in view of what Dr. Mazlan has just discussed, and we heard Dr. Mazlan mention some of the big giants who have already implemented digital twins, right, Prof? What opportunities do you see for our SMEs in the country? Can they capitalize on this?
Oh, thank you, Dr. Sharia. Definitely. If we view this last video, it's also sending a message down to many of us that, these people are at the forefront and they have already invested billions of dollars into this kind of initiative. So what chance do we have for developing countries like Malaysia? So the only way to move, to bring us closer to the first world, how I see it is we have to look at, for example, I'll give you an example. We have open source. Okay, we have open source versus proprietary softwares, for example.
Right. So
the mindset which Dr. Mazlan is trying to highlight here also encroach into this challenge where many of us may not want to move and adapt to this kind of approaches where you may get something almost free, but yet you want to pay for something which is relatively expensive. So let me drive home what I'm trying to say. The way that Malaysia can move forward, especially our SMEs, is to go into a mode, we call it learn more, discover more, and share more.
right.
So which means at the heart of this initiative or approach is altruism, selflessness, not to be selfish. You see, for open source, you can look into the source code and you can see whatever the thing that is revealed there. But for some of these proprietary softwares, you'll be not given access to see what are the codes there. I'm giving you an example. So at the same time, you have this community of practice where they are sharing, so that you learn more, you discover more, and you share more. So in this case, when you do this, you bring that level of competitiveness down to a certain manageable level where you're empowering the consumer. So instead of you are always at the mercy of the producer. So the mindset here is for us, for the SMEs in Malaysia in particular, to move forward, we have to work together as a team.
Right, Prof. Before we move on to, and we're very excited about Dr. Rizal talking about the SeIRAS, I have two questions, Prof, for you. One is that given your vast academic and industrial experience in terms of research and development and teaching and holding administrative position in the university, so you have interacted with a lot of people. Is the technical community in the country ready for this transformation at this point of time? That's my first question. And the second one is that Dr. Mazlan highlighted that it's a painstaking process for the universities to update their so-called curriculum. So what is your advice on that?
Okay, thank you, Dr. Sharia. The first one is we have to accept that the pandemic, COVID-19, is a disruption. Okay, we have to agree on this because we have now used the term the new norm. Okay, and then whatever is now normal is not normal. Okay, and at the same time, which is very interesting to me here is we mold this into what we call as a cause and effect framework. So you have a disruption in the form of C-19. So that is the cause. And then we have the effect based on the cause, which is the pandemic. So in terms of practicality, we have now adapted to teaching and learning online. So that you say effect, some form of way of we are trying to handle the cost. So the effect comes in the various forms now. We have introduced things like working from home, teaching and learning online, and many other initiatives. Okay, wearing the face mask, SOPs, something that Malaysia, ironically, is much better than America, United States. So with that in mind, how fast we have reacted to the cost, which is the pandemic, is, I would say, remarkable. You see, I started off saying at the beginning that if we take the example of digital twin, it is a combination of mature technologies. That's why not many of our institutions, higher education, even in schools, have really that difficulty to adopt teaching and learning online. Of course, the challenges are still there, but we can easily now accept that as the new norm. You see, so the first question I'm trying to say is, yes, we have demonstrated as a society, as a nation, that we can adapt to the cost, and we have taken drastic steps to address so that we have the effect. And on the second mode, you see, when we talk about how fast universities are adapting to this new norm, the new normal and so on, it has already been in practice many years, that the collaboration between the industries and the universities, the academia, have been ongoing. See, the only problem, I guess, is they have yet to find a middle ground on how to reconcile somehow, but now it has reached to a certain level where we cannot wait any longer. And we need to find this middle ground where both sides will be able to, reconcile and come up to some kind of agreement to address things that what Dr. Mazlan said, that technologies are also moving, evolving, disruptive. So things are now, changing very quickly. So as far as infrastructure and the processes in the university academia is there, but we need to work closer with all the stakeholders to address, things like this pandemic C-19. Thank you.
Terima kasih, Prof. Maknanya kalau kita kita mampu untuk mengendalikan digital twin teknologi ini selagi mana kita bersedia untuk menerima perubahan, ya.
Ya, betul.
Terima kasih. Okey, kita ke soalan seterusnya, Dr. Rizal. Dalam tajuk webinar kita pada hari ini, tajuknya SeIRAS, Digital Twin dan IR 4.0. Ada perkataan SeIRAS di situ. Mungkin Dr. Rizal boleh jelaskan apakah yang dimaksudkan dengan SeIRAS?
Kalau dibenarkan saya share slide boleh? Can I share my slides?
Of course.
Can, yes, sure.
Alright, can you guys see that?
It's coming on the way. Yes.
Yeah.
Yes. Okay, so SeIRAS stands for Secure Industrial IoT Replica with AI Systems, right? We call it SeIRAS because it just sounds very cute like that, right? So because twins are cute, and digital twin is very technical. SeIRAS meaning identical twins sounds fitting for this project. And our goal, basically, if you look into the ecosystem, the whole world has a physical layer, and we want to build a digital layer. And a lot of these things are maturing, and we SeIRAS goals is basically to help SMEs trying to participate in digital twin. Now, in the past, you see, let me jump a bit, sorry. In the past, we see big companies dealing with this, right? Most of this are big businesses. We're talking about Microsoft, Azure, Bentley. These are all big companies, Siemens, right? But what about our SMEs? Our nation Malaysia is basically built by SMEs, and they make about 97% of the country's manufacturing sector, right? It'll be very difficult for them to enter digital twin technology without proper guidance, without proper help, without proper test beds, right? And what we want to be as SeIRAS here is that, to provide the expertise, whether you're in agriculture, whether you're in healthcare, city, construction, manufacturing, right? So IIUM would be the one-stop center where we share our ideas, just like Prof. Reza is talking about. Try to do experimentation as test beds. We gain local industries who, like Dr. Mazlan, who works with IoT, so that we integrate all of these solutions and make it affordable for SMEs in Malaysia, right? This is the only way for us to, if not overtake, maybe, run almost in parallel with other big companies, right? So, we have a lot of local developers who are coming out with their own IoTs, and there's a lot of dimensions here that needs to be addressed. We're talking about, modeling and simulations. We have talked to several partners in these areas, local developers in AI, product and optimizations, and some of the enhancement for human-machine behaviors and stuff. So a lot of these things requires multifaceted approach. From we're talking about training, we're talking about having a test bed in this development. So what SeIRAS has started to do is that we have approaches a lot of several companies in several sectors. When we talk about security here, we work with Cybersecurity Malaysia. We hope to work with IoT companies that provides IoT infrastructure. We've talked to certain manufacturer of devices like Johar Corporations. We talked to AI companies like Human Logica, right? So these are companies that local made, right? They have they are working in coming out with a superb solutions. And like Prof. Reza said, if we share our expertise, our ideas, we can come up with a solution that is affordable for SMEs. And the whole idea is to make it work for Malaysia, because we are built out of SMEs, right? A lot of our businesses are from the SME sector, right? And SeIRAS would be the place where people would come and share ideas, to get training, to train their staff, to get experiment done, or validation on their product, right, and consultancy. So I welcome the public to come with us, figure out on what future dimensions in digital twin that we can work together.
Everyone is welcome to KICT, our cybersecurity center, with the new project SeIRAS, as Dr. Rizal explained, on the thought of local made, and that the SMEs are the major driving forces in the country. I would like to ask all of you perhaps a final question as we head towards the end of this webinar, which is that what is your advice, briefly, to our youth? Because it's the youth that will be taking over. How do they prepare for the emerging landscape. Prof. Riza?
Okay. The thirst for knowledge, dahagakan ilmu. Okay, for Muslims, if we look into the historian, the famous historian, Franz Rosenthal, he was looking into the history of the success of Islam. So, according to him, ilm in Arabic knowledge is not just knowledge. According to this famous historian, ilm or ilmu in our bahasa Malaysia is Islam, according to him. So it's not just about theory, it's about practice, it's about education. So the thirst of ilm or dahagakan ilmu ini, if we can instill this in the mind of the youth, of the Muslim world in particular, it will help them to face the challenges and also find the opportunities to bring about significant changes. Thank you.
Dr. Mazlan, what is your advice to the youth?
I think similar to what Prof. Reza mentioned, it's about knowledge too. I believe that continuous learning should be embedded with oneself. As mentioned earlier also, that the technology is very fast and keep on changing. So the youth needs to be aware about the technology trend. Take a look at what's coming in the 3 to 5 years down the road. Ensure that they are well prepared and they can be one of the earliest innovators in that part. And of course, whatever technology that you want to build, ensure that it will benefit the society too. All right, thanks.
Dr. Rizal, please add what you think being teaching the youth. What's your advice?
To me, the technology that's, what we teach in school is mostly theory. And the industry is moving really fast. But, a lot of people actually thinks that, industries are not sharing information. But, if you go into, if you get into technologies that that's popular now, you see that, there's forums, they are talking about it. There are very helpful people in there, and all of this, we're talking, technology is like, cloud computing today relies on many things. One of it is Kubernetes, and it's being implemented for IoT edge computing and a lot of other things. And I encourage, people in technology, whether you're technical or whether you're less technical in computer science, to learn about cloud infrastructure, AI implementation, because you need to know the big picture, right? So even if you don't know a lot, you have to be an expert in one area, but you still need to know the other areas so that you know the big picture and you can provide better value to sell yourself, right? When you join the working force, right? And you can see further in providing solutions and be part of a company in achieving solutions that are, looking ahead, right? So I know it's difficult. A lot of people want to stay in their own area, but it's not the case anymore, right? So you have to know a lot of things at the same time, be an expert in a certain area yourself.
Thank you, Dr. Rizal. We know we're running out of time, but I would request all the panelists just to take perhaps a question each, if you would allow, because our viewers have put in a couple of questions, but then you might just go through one question each. Is that okay?
Yeah, it's fine.
Okay. So Prof, this question is is for you. Ammar asks, does a degree in IT or CS guarantee a job now that the market demands digitization in their business?
Okay, my answer is it depends on the definition of job. As far as I'm concerned, when you get a degree, a proper formal training in universities, end up with a scroll, perhaps a transcript, then the job that we are concerned with, whether you are, some people call it entrepreneur, some call it working for a company, working for the government, self-employed, furthering your education. As far as I'm concerned, it depends on how you define the job. The way we have been trained formally means we are able to think critically, make decisions, and analyze. So to me, whatever you do, if you take it seriously, be it doing arts, social sciences, physics, you are being coached, you are being taught, and you, by the end of the day of the 3 or 4 year program, you are an established human being with a sense of purpose that you know what you have to do. So to me, yes, it guarantees you a job. So it depends on the definition of job.
Okay, Prof, thank you. So it's more about the process itself rather than just having a particular degree, if I understand correctly, Prof, right?
True.
Okay, thank you, Prof. Dr. Rizal, our Muhammad Badhoun is asking, how would operating system be an important part of digital twin implementation?
Okay, so when we all of this infrastructure relies on some kind of an operating system, right? And because of how things are implemented on the cloud, there are so many different approaches to this, right? So some people requires a serverless implementation, some requires a infrastructure, some areas requires just storage, right? Now, as you work on learning about operating systems and how the softwares that run on it works, you also have to understand at each layer the type of services that the particular software or operating system needs to provide. So knowing this, then you would, there's a lot of areas that you need to learn in that sense, right? So, whether you're talking about serverless architecture, then how would you implement there? If you're talking about infrastructure only for networks, how would you implement it there? And, this would obviously requires different requirement of operating systems needs. And also, it's a whole area on its own. If you have a chance, get certifications on one area, it will be good for you. Then you can target in one of these areas in cloud computing.
So the role of operating systems looks like quite major in the implementation of digital twins.
Yeah.
Sure, Dr. Zal, go ahead.
Yeah, I mean, it would, you cannot run away from it, right? Because software needs to run on OS.
Right.
It's just that, how you would, depending on which layer you are, then you have to know the difference on how it is being used.
Thank you, Dr. Rizal. One last question for Dr. Mazlan. It's a few questions that I'm trying to combine together because they're aiming at the same thing. I think what they want to know is that how do you see Malaysia in 10 years from now in regards to digital twin?
Is that a combination of question or a very
Yes, it's a couple of questions. I tried to just lump sum them into one.
Okay, I think again, how do we, I don't have a crystal ball to see where Malaysia going to be in the next 10 years. But this is what I hope. I would like to see what Malaysia going to be. We have been I think we have discussed it even with myself and Prof. Reza. Might be a slightly different idea. But what I'm saying is that we have been in a consumer space. We are the consumers, consumer product, consumer nation. What I mean is that a lot of products that we use today is from other countries, from other people. It's not the one that we really design. Only a few small percentage that we design and we use it. What I was hoping in 10 years down the road, if we are, talking about IR 4.0, new technologies and all that, we want the talents to build our own technology and products, local products. So in 10 years down the road, I was hoping that, maybe we can become a producer nation, the one that can not only use the technologies within our country, but we also become the exporters of our own product in the future. That's what I hope it's going to be. But of course, again, as I said, we shouldn't, relax ourselves just to learn things, but we need to produce and design things. Right.
Thank you. A huge thanks to all three of you for your valuable time. We know you have a very busy schedule, but we're really glad to have you here and explain some of the hot questions or introduce at least these concepts to the country. Probably we will see in the coming years how this plays out in the context of Malaysia, which is a developing country in that sense. And Dr. Mazlan pointed out that we have been consumers so far. So, can we go that extra mile now? Can we step up from just being a consumer to a producer, at that kind of landscape? So once again, really glad to have all of you. We wish there was more time and we could more, perhaps in the future, we could expound, go in detail and depth about it. Once again, I thank all of you for being here. I thank everyone who tuned in and anyone who tunes in later, because there will be a recorded session that will be available through our Facebook page once the editing and everything is done. So I hope you are also excited as I am into the implementation of digital twins in the country. On that note, thank you everyone. Jazakumullah khairan. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
Okay, sekali lagi kami ingin merakamkan ucapan terima kasihlah kepada semua peserta yang telah mengikuti sesi webinar pada hari ini. Diharapkan webinar ini dapat memberi pendedahan kepada semua tentang digital twin tu. Dan semoga kita semua mendapat manfaat dari sesi hari ini. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.